I have an example too. What is the frequency of, it says green light that has a wavelength of 552 nanometers? Okay, so we're going to use that same equation, and that equation was, I'll go back, was c over lambda. So nu, or frequency, is equal to c over lambda. Okay, but we have a problem here, and that is the nanometers. A nanometer is a billionth of a meter. So that's going to be equal to 3.0 times 10 to the 8th meters per second. That's just the speed of light divided by this number. But I can't just use 552. I have to convert this to meters. How do I do that? We'll see a nanometer is a billionth of a meter. So actually what I can do is I can say 552 times 10 to the minus 9th. Watch how I do that on the calculator now. Okay, I actually don't have to convert it. I just have to know this 10 to the minus 9th term. So if I come back to my calculator and I say 3.0, here I'll clear it so it's easier to see. Clear. All right. 3.0 second function e 8 divided by 552 second function e negative 9. And I get my answer. And the answer is 5.4 times 10 to the 14th hertz. Now, that's a decimal right there. Notice one thing also that I do on the calculator right here is I don't write 5.43478. I just usually round to, like, we say the second significant digit. We haven't really learned what that all means and all that. But just don't write too many digits, I think, is a good thing to understand. Okay? And then the third example is actually going in the other direction. All right, I have the frequency. It's asking what the wavelength is. So if I know what the frequency is, what's the wavelength? Okay, it's really the same equation. I could say that the wavelength is equal to c over the frequency, or nu. So I'm just going to say 3.0 times 10 to the 8th meters per second divided by the frequency, which is 8.8 times 10 to the 14th hertz. And this will give me the answer in meters. And now I go to my calculator. Clear it out here. 3.0 second function double E8 divided by 8.8 second function E14. This is going to be a tiny number, which is typical of light, and I get 3.4 times 10 to the minus 7th meters. That's a minus 7th. 3 point, write that again, times 10 to the minus 7th meters. That's, by the way, as a side note, that's 340 nanometers. You would multiply that by a billion. So to get from meters to nanometers, you'll times it by 10 to the 9th. In fact, let's just do that. I would say times, answer times, 1, you say 1, by the way, double E9, and I'm going to get 341, actually, nanometers. So the you could then look on that table. In fact, just for fun, let's just do that. So if I have light that's 340 nanometers, okay, what kind of light would I have? Well, 400 nanometers is ultraviolet, and as we go down here, they get longer, right? So 340 would be just above the violet, and so that would be, what kind of light? That's correct, it would be ultraviolet light. This would be in the ultraviolet spectrum, like that burn your skin, you know, that kind of a thing. Okay? So, that concludes podcast 3.1. We're going to be learning about light. So we've learned a little about light, and as we understand light, we'll be able to understand the stars, pulsars, black holes,